Lesson 73 in Algebra is Algebra 1, third edition of Saxon. Deals with two different things. The first is very easy, very fast. It's more factoring. It's factoring the difference of two squares. And what that simply means is if I look at this first term and this second term, and I see that each one of those is a perfect square, then the way you're going to factor that is x plus y, x minus y. And here, 2p plus 5, 2p minus 5. And then this one I'm going to come down here, m plus 4, m minus 4. And that's really all there is to it. It's very, very simple. Let's do a couple more. Alright, so let's do some examples here. We have negative 4 plus x squared. Well, we're going to turn that around so it'll be a difference of two squares. X squared minus 4. Both of these are a perfect square, so I can simply say x plus 2, I'm sorry, not 4, 2, x minus 2. Another example, 49 m squared minus a squared. Alright, I'm looking for the square root of each. 7m plus a, 7m minus a. Alright, and finally, it's given to us in the book, example 73.3, as negative 36a squared plus 25y squared. I need to turn that around so that it's a difference of two squares. 25y squared minus 36a squared. And then I can factor 5y plus 6a, 5y minus a. Alright, great job. Now we're going to turn towards the next part of the lesson, which is probability without replacement. Okay, a couple of lessons ago we talked about probability, and we're going to continue on in that thought with this lesson, except the difference is in this lesson we're going to talk about probability when they're without replacement. Okay, so we'll do some with and without replacement so that you can see the difference. Alright, an urn contains 3 black marbles and 5 white marbles. A marble is drawn at random and replaced. Then a second marble is randomly drawn. What is the probability that both marbles are black? And in B, if the first marble is not replaced before the second draw, what's the probability that both marbles are black? Well, we start out with 3 black and 5 white. And let's say we're going to do our first draw, and we're going to take a black one. Alright, so the probability was we had a 3 in 8 chance on the first draw. Now, let's say that we put that back. Okay, let's see. We're going to put that back. So the second time, what is the probability that we're going to get a black marble? Well, again, we have 3 black, 5 white. So we have a 3 in 8 chance of getting a black marble that time as well. So we multiply across and we get 9 out of 64 times that would happen. However, if we make that first draw and we had a 3 in 8 chance and we do not replace the one we took out, the one black, that changes things because now we only have 7 total marbles, and of those 7, only 2 are black. So that makes a big difference. So now we only have a 6 in 56, which will reduce to 3 out of 28 times that would happen. An urn contains 4 red and 7 blue marbles. 2 marbles are drawn at random. What is the probability that the first is red and the second is blue? And we're going to do it with replacement and without replacement. Alright, so with replacement, the probability that the first is red, well, we had 4 red, 4 out of a total of 11 marbles, and that the second is blue. Now we're going to need to put that red one back. So let's see. Again, we have 11 total marbles, and 7 of those are blue. Then we multiply across 28 times 110. Now, if we, I'm sorry, not 110, 121. What was I thinking? $121. Alright, and that is with replacement. Now let's do it again without replacement. The first one is not going to change. We start out with 11 marbles, and 4 of those are red. However, if we do not replace that red marble, it is gone. And now we only have a total of 10 in the jar. Now of those 10, 7 are still blue. So in this case, our answer would be 28 out of 110, and that would reduce to 14 out of 55. Okay, so see, it makes a lot of difference whether you replace it or do not replace. Let's do our practice problems. First, it says factor these binomials. These are the difference of squares. So we're going to look for the square roots, basically, of each one. Okay, square root of 8 is, 64 is 8. X squared is x. We know we're going to need a plus and a minus. Square root of 81 is 9. Y. So 8x plus 9y, 8x minus 9y. Now in B, we're going to need to turn this statement around. 100m squared minus 25, so that it will be a difference of 2 squares. And then we will factor as usual. The square root of 100 is 10. M plus 5 minus 5. Alright, the square root of y to the 4th is y squared x plus minus the square root of 169 is 13. And the square root of z to the 10th, remember we actually are adding, would be z to the 5th, 13z to the 5th, because z to the 10th is actually 1, 2, 3, 4, 5, 6, 7, 8, 9 times. An urn contains 4 purple marbles and 3 pink marbles. 2 are drawn at random. What's the probability that both marbles are purple if the marbles are drawn first with replacement? All right, so we have a total of 7 the first time. If we put that marble back, if we replace it, we have 7 the second time. And out of 7, 4 of those are purple. So we would have a 16 in 49 probability of that. Now, if, in fact, we do not replace, then the first one stays the same. We have 4 out of a total of 7. But then let's say that one of those purples that we took out, we do not replace. Now we have a total of 6 marbles, and of those 6, 3 are purple. Now I know I can reduce 3 over 6 and put 1 over 2, make it easier on myself. 4 times 1 is 4, and 7 times 2 is 14. And that would be 2 in 7. So we have a 2 in 7 chance of that happening. And finally, an urn contains 5 orange and 6 blue marbles. 2 marbles are drawn at random. What's the probability that the first marble is orange and the second is blue? And we're going to do it with replacement first. 5 plus 6 gives us a total of 11 11 marbles. And if we replace it, there's 11 on the second. Alright, so the first marble is orange, well, we have 5 orange, so it would be a 5 out of 11 chance. And that the second is blue, there is a 6 out of 11 chance. So we have a 30 in 121 chance of that happening without replacement. If we have, if we take one of these orange marbles right here on the first draw, then we had a total of 11, and 5 of those were orange, but now we only have a total of 10. Of those 10, 6 are actually blue. And let me see, cross-canceling here would make this a little easier. 6 divided by 2 is 3, so 1 and 3 would be a 3 in 11 chance. Good job. I will see you back next time for Lesson 74.